I figure if we can teach sand to think, I can teach lines to multiply. I've got 32 times 21 here, and I just don't want to do the standard algorithm. Instead, what I'm going to do is count up some dots. The dots are going to come from the intersections between these four sets of lines. The blue lines correspond to the 32, and the pink lines correspond to the 21, and I'm going to count up the dots in three sections: the top, the middle, and the bottom. At the top, I can see 6 intersections between the lines. In the middle, I can see a total of 7 intersections, that is 7 dots, and at the bottom I can see a total of 2 dots. And wouldn't you know it, 32 times 21 just happens to be 672. I forgive you for your skepticism. Perhaps this is one of those weird tricks where I've specially chosen the numbers. But I can select other examples and this keeps working. Consider something like 21 times 42. I've got 8 intersections at the top, I've got 8 intersections in the middle, and 2 intersections at the bottom. And indeed, the product of 21 times 42 is 882. Why is it that this works at all? Go back to that first example where we did 32 times 21. I'm going to draw 32 as a series of 5 blue lines. 3 blue lines up here representing my tens digit for 32, and 2 blue lines down here representing the ones digit. Then I will similarly draw 2 lines for the tens digit of 21 and 1 line for the ones digit. When we are simply counting up the intersections of these lines at the top, what we're actually doing is taking the product of our 2 different tens digits. Again, there are 6 intersections there, but what that actually represents is the product of 600 that we get from 30 times 20. As we count up the intersections across the middle, we're finding out how many tens that we have. 1, 2, 3 of the tens are coming from the product of this tens digit of 3 and this ones digit of 1. That is the 3 blue lines and the 1 pink line. And then these 4 more intersections over here on the right are coming from 2 times 2. The 2 blue lines representing the ones digit of 32 and the 2 pink lines representing the tens digit of 21. But when I gather those all together, that's just 7 different tens. That's the 70 that's part of our product. Finally, at the bottom, I have 2 different intersections, and this represents the product of our 2 ones times our 1 1 from the 32 and the 21. 2 times 1 is 2, and so that is 2 units that add together to make this total product of 672. I've heard this given a lot of names over the years. I've heard it called the Japanese line method, the Chinese line method. It is in fact frequently used as a kind of viral social media clip like, oh my goodness, why didn't they teach us to multiply this way? And there are kind of 2 answers to that question. One, we did teach you to multiply this way. This is in fact the standard algorithm, it's just the standard algorithm grouped and visualized a little bit differently. The second answer is, yeah, it goes great when you're multiplying 32 times 21, but if you're multiplying 73 times 79, not so much.